Hi there and welcome to my annual summary of my solar production for 2023. So in this video I'm going to look at how much I've generated during the whole of the year, how much I've exported, how much I've spent on electric with importing, and how much I've used on gas, etc, etc. And at the end of the video I'm going to kind of sum it all up and try and work out how much I've spent in total for the year and how many years it's going to take to pay off my solar panel system. So let's get started. So let's take a look at the whole year of 2023. Now I've had a full year. My system was actually installed in March 2022, so I haven't got a full year for 2022. So this is my first kind of proper full year to look at. So in total for the whole year of 2023, 5.9 megawatt hours, so 5,900 kilowatt hours in total, and if you divide that up by 12 you get roughly 491 kilowatt hours a month on average. And if you take 5,900 kilowatt hours and divide it by 365, you get an average of 16 kilowatt hours per day on average, obviously with most of those being during the summer. Certainly would like 16 a day in December, but there you go. So yeah, so January started off with 243, nearly 244 kilowatt hours. So we should see January being a lot better than the December we just had. February we start ramping up even more, 347, and then just a little bit more, 400 in March we had this year, or last year should I say, in 2023. And then when the clocks change and the days start to get longer, you'll see a really big improvement. If you've not had an April before, a big increase, 679 kilowatt hours in 2023. A little bit more in May, 735 kilowatt hours, with the peak last year being in June with 835 kilowatt hours. Although I don't know if you remember, the July 2023 was not a very good month at all for weather. Even though it seems really high and we got 676, that should have been one of the best months. It should have really equaled June, which was kind of on 835. August was a little bit better than July at 703 kilowatt hours, and then we start the real coming down. The 555 kilowatt hours in September, 369 in October, 244 kilowatt hours in November, and then the sorry state of affairs, just over 100 kilowatt hours in December. Okay, so we've spoken about the solar generation. Now I just want to quickly come into Octopus and have a look at the electricity that I actually used. So this is the electricity use for the whole year. It's been a bit of a mixed up year really, because I started off on Octopus Go and then I moved to Octopus Intelligent. And so this use really, it's been used on obviously topping up the battery overnight. It's been used by the house when the batteries run out. The eddy for the hot water heating, it's been used for that, and also for charging the EVs as well. But as you can hopefully see here, obviously when solar is not its best for the beginning of the year, energy consumption has been the highest. So in total, this is off peak and day rate as well. So 585 in January, 632 in Feb, 554 in March, and then as I say, April is a big turning point really in solar. So those middle kind of months, hardly anything, 35, 10, 50. And then as you come out of sort of September, 350, 335 in October, 545 in November, and then finally 538 in December. So you can get away with using very little electricity during the summer, but it really does depend on how much hot water you're using, whether you've got teenagers in the house, how many miles you do with your EV, how much charging that needs, things like that really. So in total for the whole year, I have used electricity wise 3,685 kilowatt hours at both peak and off peak rates. But I'll break that down in a little while in an Excel spreadsheet, and I just want to talk about sort of exporting first. So here's the export page from Octopus. As you can tell here again, you know, during the summertime, obviously when there's more sun, you've got more chance of exporting, but how much you export is really down to what tariff or rate you're on for your export, and how much you obviously consume yourself, and how much sun is in the sky too. So beginning of the year, I was on only a 4p rate for my export, so we used most of the energy that we could. But obviously when we changed over to, well, I moved to Scottish Power. That's why this bar chart doesn't include several months, because Octopus weren't recording my export. I moved over to Scottish Power for 12p, and then we were trying to export as much as possible. Then I moved back to Octopus when they raised the export rate to 15p whilst I was on Intelligent. So things have definitely changed last year, where we were using everything that we could when we were only getting 4p, but now we kind of export nearly everything we can. Now we're getting 15p. So let's just have a quick run through the months. So 29 kilowatt hours in January, 64 in February, 84 in March, 152 in April, May 135, June 135, nearly matched, July 213, so a big peak there, but that could be due to holidays and not being in the house, things like that. And August 47, and then December, a big jump to December because we were with Scottish Power for those months in between, and I'll show that on the Excel spreadsheet now. Right, so here's the spreadsheet. We've got the months down the left, of course, and then the generation in kilowatt hours in this column, the 5,890 kilowatt hours. And then the export that I've just spoken about is in the columns right up to August. Now, Scottish Power don't tell me, you know, month to month what I've exported in the reporting. So I just do a meter read, and then they just paid me the difference, really. So I know how much was kind of used. So I've really just averaged that over those 4 months. It's not brilliant, but at least I've got some no gaps, and I've got some numbers in there. So 1,310 kilowatt hours exported, 1,310. And you can see here in the E column, my price per kilowatt hour, I was on 4.1p all the way to July. And then I moved to, in August, I was on 12p with Scottish Power, and then back to 15p in December with Octopus. Right at the time when there was hardly any export, of course. But, you know, low values for, you know, the months when we were using a lot of it, obviously, because it wasn't worth exporting it at 4.1p. And then we were averaging £16 a month when it was 12p. And then in December, we just exported 7p worth. But for the total for the year, I exported just over £100, £101 and 41p, which, you know, I'm hoping next year, now where I'm on a constant 15p rate, which is a lot better than the 4p rate, that we'll be sending a lot more out during the summer months and through the year. And I'm hoping that that figure of £100 could possibly triple to 300, maybe even £400. We'll have to wait and see. So now I've brought in the electrical daytime and off-peak costs. So for daytime use at 1,416 kilowatt hours, and off-peak 2,269 kilowatt hours. Now I did lose, these numbers aren't quite correct because I lost access to my Octopus data for the few months when I was with Scottish Power. Yeah, funnily enough, when my export was with Scottish Power, I couldn't access my data. So suddenly when I did come back to Octopus for my export, it suddenly started working again. So that must have been the problem. So some of these numbers are not quite correct, but I've kind of carried them on through and added them up. So I've included the daytime and off-peak costs in those months where I had the gaps. So the numbers, the costs, should I say, are correct. And so are the usages, but they might not be in the right columns. So total kilowatts, 3,685 kilowatt hours used for the year. And I've also included the saving sessions in here just for the end of 2023 in December, where I managed to get £41 and 27p. So let's have a look at some totals. So when looking at the totals, 2023, we imported daytime 214, off-peak 171, which totaled £385. We exported £101, and the saving sessions for December added up to £41. So 385 minus 101 minus 41 gives us a total cost for my electricity for the year of £243.18. So if I divide 243, wow, by 12, yeah, you know it, £20 a month on average throughout the year for the electric. So just coming on to gas, I just wanted to have a look at this just to prove that I don't use any gas during the summer at all, and that we completely really turn the boiler off and we have the eddy heating the hot water, either by solar, which we did last year, or overnight, as we do a lot of the days, or we will be next year. Most of the gas obviously usage is January, February, March, and then October, November, December. So this year I used 11,335 kilowatt hours. When you work it out for costings, it's just over £1,100, so £1,117 and 23 pence. And don't forget, last year we had some government payments as well, very nice. January, February, March added up to £201. They were showing up in my Octopus Energy account as £67 per month. So gas for the year, as I say, was 1,117. If we minus the £201 from the government, gives me a total of £916 for the year for gas. And if I divide that by 12 months, I get an average of £76 a month for the gas. The boiler is a Valiant boiler. It's about 9 years old, although this house isn't amazingly insulated, although the outer walls have been done. It is a fairly airy house, so that's why that number is quite big. It is a 6-bed house as well, although we do turn off a lot of the radiators and keep some of the doors shut on some of the rooms. Regarding my gas costs, I did have a comment from someone on one of my videos talking about the gas tracker on Octopus, and I just went and had a look online, and I came across this website from Google search showing the tracker prices. So this is Eastern England in December. So the rate now is kind of 7 pence on flexible. Is that right? Flexible Octopus? Yeah, on the normal gas standard rate. And as you can see there, during December, the green line was well below that on the tracker. Now, obviously, the tracker can go up. It's capped at 30 pence a kilowatt hour. Wow, for gas, you wouldn't want it to be that for a while. I can tell you that. And there are a few terms and conditions about moving to this tracker gas tariff. The first one is that I need to have a gas smart meter. Well, mine's not working at the moment because I'm waiting for a dual band booster to come into stock to be fitted to it so it can talk to the electric one. It hasn't worked for well over a year now, so that may stop me going on to this tariff. There are a few other conditions such as I think it said you can move to it, but to move off it would take a couple of weeks, and then you wouldn't be allowed back on it again for like 9 months. So you've really got to be sure and not be freaked out if the prices do start going up for a little while. But if I just looked at the kind of prices of December, the averages, then I kind of see that, you know, throughout the December month, it was 5p, but it's still cheaper than 6 and 7. And if I scroll down, I just brought this into Excel and totaled it up and then averaged it by 31 days in December. So 4.5 pence per kilowatt hour for gas was the average. So certainly at the moment, that looks like something worth moving to the tracker gas, as opposed to paying just over 7 now. Obviously, these prices could change at any time, but over the last few months, they've always been around the 4 and 5 pence. So at the moment, it looks like a good idea. So thanks for that tip in the comments. Right, so after all of those figures, let's try and work out some savings and how long it will take me to pay off the solar setup. So this is quite difficult because of how much electricity you've saved that you don't know about, such as, you know, EV, how much, you know, electric went into the EVs really via solar or via overnight is quite difficult to work out basically because overnight some of it's also going in the battery and other things, and the hypervolt kind of doesn't really tell me what's gone in from solar as opposed to what's gone in from the grid. So this is kind of a rough guide, really. So to start off with, I used to work out that before I put the solar system in, that we used roughly 14 kilowatt hours per day on average. So that works out to be 5,110 kilowatt hours a year. And if I take the average kind of price for the year per kilowatt hour for electric of 29 pence, the peak rate, I come out with £1,481 for the year it would have cost me. So you saw me just do the sum for the electric costs. So the electric cost was 385, but if I minus the export of 101, minus the saving sessions of 41, I came up with £243 for the year. That was what it really cost me for my electric. So if we take that 1481 and minus the 243, we could say that I've saved £1,238 this year on electric. But I've also heated the hot water. Now, most of this heating of the hot water this year has happened via electric. So I worked out previously, based on gas bills from before when I had the solar installed, that my hot water roughly cost me about £1 a day. So I'm going to say £1 a day. So £365 a year for the hot water, I'm going to say. So the 1238 that I've saved already plus the 365 gives me £1,600 that I've saved. And also don't forget solar EV charging. I haven't been able to sort of add that in or try and compare, you know, how much I would have saved by having an EV compared to petrol or diesel, or, you know, let's not talk about depreciation of the cars though. So 12k install roughly at the time when it went in, it was 11.5, but then I spent £500 on the Eddy, so let's say 12,000 divided by the 1,600 that I think I've saved in the last 12 months works out to be 7.5 years payback. So that's probably about right, although I think it should be a bit lower than that. So in March 2024 it will be my second year. They will have been in 2 years already. So that's not bad, 5 years to go. But I think we can decrease that payback time. And why do I think that? Well, basically now because things have settled down a bit more. And instead of getting 4p export, I'm getting 15p. And the way I'm using the system has changed a bit more. And I'm hoping there's going to be some more saving sessions, as this year was the first year that I participated in the saving sessions. I didn't do it last year. So this year I'm hoping there's going to be more saving sessions. So I'm hoping I'm going to be able to save an extra £50 with the saving sessions. And I'm hoping to export more and actually make, instead of £100, possibly £300 more. So this is a rough guess here. So £350 more I think I can save. So that would take us to £1,950 for the year. And then if I divide that, obviously 12,000 for the install again, divide that by 1950, I get 6.15 years. So we're really bringing it down now. So I think that is kind of more accurate. I think it's somewhere between 6 and 7 years on average. As obviously this thing keeps moving around, the more the electric prices, peak rate prices, off peak rate prices change, or the more that I can save, or the more saving sessions we have, or the more I can export, blah blah blah. So this is always going to move around a little bit, but I'm quite comfortable in I'm going to say 6.5 years, and I'm coming up to 2 years, so 4.5 to go. So that's what I think anyway. So that's it for 2023. Hopefully next year I'll have a simpler year and I won't be moving around with the export rates changing all the time. Hopefully I'll stick to the same tariffs in 2024, which will make the calculations a lot easier. And hopefully we'll also see some more saving sessions to save me some more money. And I'm hoping to actually export more and get paid more for my export in 2024 to also save me some more money, and possibly look at changing my gas to the tracker rate as well. I'll have to look more into that as well. But thanks for watching. I hope you enjoyed the video. If you did, don't forget to give it a like and leave a comment below, of course. And don't forget to subscribe if you're not a subscriber already. But thanks for watching, and I'll see you soon.